Okay, Monte Carlo simulation. Monte Carlo simulation is, I guess, an additional step in scenario analysis. We uh, um, we create a set of variables, potential outcomes, so forth, and we can use a computer to model those. The the Monte Carlo simulation gets its name from the European casino in Monte Carlo. The the it is um, also used to evaluate gambling strategies, among other things. So, so the imagine a blackjack player who wants to know if she should take the third card whenever her first two cards equal 16. She could attempt to do it with by trial and error, but she could also uh, this could obviously cost a considerable amount of money. So she could play thousands of practice hands, and that's basically what Monte Carlo simulation is. They and just an aside, you can run Monte Carlo simulations with replacement, where so for example, and this wouldn't be the case, but in this case where the card would be put back in the deck with which is called replacement. Um, the in the typical card uh, scenario analysis or Monte Carlo simulation, you would do the simulation without replacement, but it can be done either way. So the Monte Carlo simulation have some capital budgeting projects is done in the same with the same ideas in mind. So, uh, so it's often viewed as a step beyond sensitivity analysis or scenario analysis because it's obviously more complicated. You're going to use uh, as many potential outcomes as you possibly can. The the interactions among variables are specified in the simulation. The the so at least theoretically, the methodology provides a more complete analysis. But just like any analysis, the 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 results are only as good as the information that you use. So if your data is flawed, then your results are going to be flawed, no matter what type of analysis you use. So pharmaceutical industry pioneered applications using the methodologies, uh, not widely used in other industries. So in Monte Carlo simulation, first thing we do is we specify the basic model. Then the critical part, we specify a distribution for each variable in the model. So, for example, in investments, we like to assume that returns are normally distributed. Normal distributions are easy to work with and so forth, but they can also create their own problems. The but the again the specifying the distribution is a very critical step. So so the computer will draw an outcome just like drawing a card. So and then repeat the procedure. Then we calculate an NPV, and this you tell the model how many times you want it to repeat. In most cases, it would be like 100 times or something of that nature. But since we're using a computer, it doesn't matter how many times you repeat. You repeat. You just tell the computer how many times. But the more accurate your data is and your distributions, the more accurate your results are going to be. So, real options. So, one of insights of modern finance is finance theory is that options have value. So the we talk about being out of options. That's a problem. If a company is out of options, then they're likely filing for bankruptcy. So because corporations make decisions in a dynamic environment, that they do have options to consider when they evaluate projects. So, for example, option to expand. So, the has value if demand turns out to be higher than the company expected. Option to abandon has value turns out has value if demand turns out to be lower. Option to delay. One of your homework problems looks at the option to delay. So what we have to do on the option delay is we calculate the value of the projects based on various start dates, and then we present value them all back today to calculate the NPV. So discounted cash flow and options. So we can calculate the market value of a project as a sum of the net present value of the project without options, and the value of managerial options is implicit to the project. So the market value of project is equal to the NPV plus those options, whatever they may be. A good example would be comparing the desirability of a specialized machine to a more versatile machine. If they both cost about the same and last about the same amount of time, if they perform the same functions, is what this is saying, then the more versatile machine would be more valuable because it comes with options. So if when you don't no longer need that machine, it's more likely to be worth more money. Option to abandon. So look at drilling an oil well. The drilling rig costs $300 today. In 1 year, the well is either a success or a failure. The outcomes are equally likely, and the discount rate is 10%. The present value of a successful payoff at one time is $575. The present value of an unsuccessful payoff is zero. So these are all 1 year in the future. So just like we did before, we take the probability of success and the probability of failure, and we multiply those by the various outcomes. In this case, they're equally likely. So 50% probability of a success, the 50% probability of a failure. So that's value is the value is $287.50 in period one. So we have to calculate an NPV based on that number. So the NPV is $300 initial cost plus or negative $300 initial cost plus the $287.50 present valued back 1 year, and so we'd have a negative NPV. So in this case, you would reject the project. So, but if we look at now, we can look at the option to abandon. So if we look at the option to abandon, so our first decision here, this is our first decision tree we'll look at. We have drill or not drill. Those are first decision. Then we have success and failure. So success with $500, failure. So failure, we have two options. We can just keep the rig and not do anything, which has a present value of zero, or we can sell it for $250. So now we have the firm has two decisions to make: drill or not drill, and then abandon or stay. The last one's coming only in the event of failure. So, so when we include the value of the option to abandon, the drilling project should succeed. So, because we have, uh, if we have 50% probability of success and 50% probability of failure, we're going to receive, uh, we're going to have a expected payoff uh, of 412.50. So we've got still got the 575 for the successful, but we put the $250 in for the sale of the rig. So that gives us a value of $412.50. That 412 replaces our 287 in our NPV calculation, and we end up with a positive NPV project. Okay, we'll start the next lecture with valuing the option to abandon.